Hello, everyone. Thanks for joining today. My name is Phil Fricks, and I work for Industrial Networking Solutions in business development in our wireless services team. Today, we're going to be talking about private cellular networks and CBRS, and more specifically, Cradlepoint's offering in that space, which is called NetCloud Private Networks. With me today is Greg from Cradlepoint. Greg, you want to say hello?
Yeah, for sure. Hey, Phil. Hey, everybody. I'm Greg Kamer. I'm a technical product manager on our NetCloud's private network team here at Cradlepoint.
Thanks, Greg. So I was thinking a good way to kick this off is the first time I heard about the concept of a private cellular network, probably going back 3 or 4 years now. When I finally wrapped my head around the idea, I was pretty excited about it, wanted to go tell a customer. And so I went out, visited one of our longstanding customers, and I said, I got to tell you about this great new technology called a private cellular network. And he kind of rolled his eyes and looked at me and said, Phil, we've had a private cellular network for 10 years with the carriers now. So maybe you should catch up on things. So, Greg, can you maybe help clarify that a little bit and make some sense of that?
Yeah, for sure. So no doubt that's true. There was that kind of a private network type thing. But the real big difference is that when we're talking about private networks in terms of Cradlepoint, the big difference is going to be the fact that you own the entire infrastructure, the core, the SIMs, the access points, or the eNode Bs, however you want to call it. That's all owned in-house. So it is a one-time purchase, and then you're not paying monthly fees to a carrier and things of that nature. So, and not only that, are you thinking through the cost and deployment, but also the security of it. Because at the end of the day, all that data can stay local to you. It doesn't have to go through a carrier core network or anything like that. So while there is that concept of a private network through cellular, through some kind of a slice or something of that nature, it's not exactly the same thing. You can think of it as being somewhat analogous to Wi-Fi, in the sense that you would have access points and a controller, potentially a controller, depending on the solution, but that would be there in-house. You're not relying on somebody else's infrastructure to make your solution work. So I hope that kind of clears it up a little bit, but it's definitely similar name, but a very different type of infrastructure and deployment.
Right. Very different for sure. So I think that's a great point, and I want to emphasize that again. When the technology we're talking about today is your network, you own it. So therefore, there are no monthly data plans. There are no unexpected overages. There are no monthly bills. Your network, you own it. So what I think that kind of maybe conjures a picture in people's head of my own cellular network. So I see the towers on the side of the road, those big things, and those look pretty expensive. So I don't know that that's the kind of investment I'm looking at. And that's a really good comparison because people are so comfortable with Wi-Fi and it's so prevalent. And certainly our message today is not that Wi-Fi is going away. In fact, I would say at INS, the deployments that we've done with private cellular and what we suggest to customers is look at where Wi-Fi has been a challenge. For whatever reason, the coverage you're trying to achieve, the mobility, so that is devices roaming from access point to access point, high metal environments, things of that sort. So any place that Wi-Fi is hard is probably a good application to look for where a private cellular network could be applied. It works differently, and I think where Wi-Fi is hard, generally, I can pull my phone out of my pocket and I've got a pretty good signal. So that's the type of environment where we've seen this technology really just, it's, you kind of have to see it to believe it. So manufacturing plants, chemical plants, warehouses, places where you still see a lot of 900 megahertz, in operation because Wi-Fi just struggles in those spaces. Again, think of large and especially outdoor spaces, warehouses, ports, campuses, where you're trying to cover a large footprint that would take potentially dozens of access points.
Yeah, for sure. And I think you definitely hit the nail on the head. We're not coming for Wi-Fi. That's not, at least for me personally, I'm a CWNE. I worked in the Wi-Fi industry for 12 years. I didn't leave the industry because I thought I was going to kill Wi-Fi. I thought I want to go help customers with a different solution to serve different challenges. Like one great example, you mentioned ports, you mentioned warehousing. Coverage is definitely a big part of that. But one of the places, and again, with my Wi-Fi experience, and I'm sure the listeners and viewers of this could potentially relate to issues you see with Wi-Fi, like sticky clients, coverage issues, things of that nature. Those are things that cellular can definitely help with. It's especially when you start getting into what you would call in Wi-Fi roaming, moving from one access point to another. In cellular, we call that handover. And so the nice thing with cellular networking is all that handover and again, what you would call roaming in Wi-Fi, it's not the same thing in cellular. Ask me how I know. But the nice thing with that handover is the fact that it's all done through the infrastructure. The clients aren't making the decision when they want to start moving from one access point to another. So it's much easier to avoid sticky clients. It's much easier to keep, data sessions up and running and not start dropping packets or even voice calls or something like that, where, I can tell you numerous times in my career where I would go help customers that were doing voice. And they'd say, hey, it sounds like when this user goes to this certain part of the building or the warehouse or wherever, it sounds like they just fall off a cliff. And it's because they're waiting to roam from one Wi-Fi access point to another. And that's really not a consideration you see too often in cellular. Now, to be fair, people have told me like, well, I've had that happen on cellular. I have drop calls. And sure, that happens. But that's just usually a coverage issue in the sense that, it's trying to migrate you from maybe one tower or one radio to another, but there's a coverage gap. So your device just loses signal. But again, all those things can be fixed with design. So it's not something that's going to go and take your Wi-Fi network. We're not saying, hey, Wi-Fi nerds, proudly like myself, hey, you need to go learn cellular, you're going to lose your job. That's not at all what we're trying to say here.
That's a great point. The roaming clients for some of the applications that we've rolled out, it's absolutely critical. If you think about it, cellular networks were designed with roaming in mind. In very simple terms, the network takes care of that piece. You don't. And that's, conversely from Wi-Fi. Wi-Fi was designed more that the end device is going to attach to an access point. It's going to hold on as long as it can. It makes the network implementation and user experience so much cleaner. So when we're getting to some of the more modern applications that are possible now with this kind of technology, so we're talking, wearables and smart devices and smart glasses. If you're roaming a facility, you might be, in a truck or a golf cart traveling a site that's several square miles in area. Or the flip side of that, maybe it's an AGV application. And, you've got high-speed autonomous vehicles that move and need to connect from access point to access point, where that happening instantaneously and reliably is critical.
Yep.
So let's talk a little bit about security as it applies to a private cellular network and sort of why inherently security is just baked in.
Yeah, for sure. So I'll kind of start at the client or what we call the UE level, right? So each device is going to have a SIM, and that SIM is going to be a physical SIM or it's going to be an eSIM. Now, those SIMs are going to hold credentials. So in the cellular world, there's no such thing as an open network like you would see in Wi-Fi, where it's just completely open. You take a packet sniffer and you start owning people's traffic. So that connection from the UE to the access point or to the radio is encrypted over the air. Now, sure, there could be security considerations where a SIM could be compromised, but even then, you don't own the whole network. It's a very reduced blast radius. So for my Wi-Fi friends out there, think of it a lot like EAP-TLS with radius. So on that side too, though, at the packet core level, or you could think of it somewhat like a Wi-Fi controller. So in an enterprise Wi-Fi network, if you want to do something like radius, for example, that has to sit off to the side generally. You may use, vendor A, B, or C's radius solution, but that's going to be a different server or servers than your controller. Now, granted, I know there are some vendors out there that have a radius light type solution. It's not the exact same thing. You're not going to get the breadth of security and policy. But when we take a step and we look at cellular networking, that packet core actually has radius's older brother diameter built in. So all that is secure within the core as well. So that data is going to be encrypted end to end. And then on top of that, the connection between your access point to your packet core, it's what's called an S1 connection in the 4G world. That S1 connection is encrypted with IPsec. So that whole data stream from the client or UE all the way to the packet core is encrypted the whole way. So all the authentication, all the encryption, it's all done in that box. You don't have to have a third-party tool or another server sitting off to the side necessarily that's going to be able to take care of all that stuff. So again, it was just the way that cellular was designed versus Wi-Fi. No knock on Wi-Fi. Wi-Fi is a great technology. It's just different, that's used in different scenarios and just built different. Just like you said with the roaming, right? It wasn't built with roaming in mind. That is from AP to AP. Yes, we do have certain things in the industry through 802.11 like R and K and V that help, but then you see different vendors that'll go out and put their own little unique spins on things and try to do something to improve that roaming experience, which are not standardized. So you still kind of run into these different implementations and quirks, shall we say, between vendor to vendor. So, but whereas 3GPP in the cellular world, that's all standardized, even between the vendors.
Okay, so I'm thinking for folks that are watching this or listening to this, so far they've heard us talk about better coverage, better mobility and roaming, better security, more connected devices. So the next question is, okay, what does this all look like? How do you put this together? We talked about SIMs a little. You mentioned a packet core. So let's build on that. What are the parts and pieces that you need for a private cellular network?
Yeah. So in our particular implementation of the packet core, it's literally just a virtual machine or two if you want high availability, redundancy. So inside the core, it gets kind of hairy. There's a lot of little things called functions under the hood that do all these different things like authentication, encryption, data plane traffic, things of that nature. So all of those things are actually put into this single VM that'll run in, say, like VMware, KVM, Azure, AWS, things of that nature, but it's all under the hood. And so again, since the Wi-Fi comparison I think is apt here, it is a lot like a Wi-Fi controller. Now, one thing to know in the cellular world that is a little different than Wi-Fi, especially these days in Wi-Fi, to be clear, that when we send the traffic from an access point to the core, all of that traffic is tunneled. The control traffic, the data traffic, it's all tunneled back. So that also keeps it encrypted, keeps it easier too, as far as like having to put VLANs out to the edge. You don't have to do that as much where you would where you're doing like local breakout in a Wi-Fi network. So it can make management a lot simpler too.
Okay, so that takes care of our core. So I'm running that on a virtual machine and on my network, and I'll call that the brains of my cellular network. And if we stay with the Wi-Fi comparison, that would relate to a wireless LAN controller. Okay, so there's that piece. And now from that, I'm going to connect access points.
Yeah, so again, it's going to be just like deploying a Wi-Fi AP, right? So they're going to run on PoE, just like a Wi-Fi AP. So that makes the deployment simpler. You've probably got tons of PoE switches. Copper cabling is well known to everybody. So that makes it simpler too. All the mounting gear is going to be put in the box. So it's just going to be much more simple. It's not any type of special cable. You don't have to run fiber to it. So that makes that deployment much more simple. But again, the APs are just like a Wi-Fi AP. Everything you need for that radio to work is built into the housing on the AP, just like you would with it would be with a Wi-Fi AP. So it just makes it that much simpler. And it's also just a more of a known entity to anybody that's ever deployed any Wi-Fi, whether even just in their home or at a very large enterprise.
And I'd say that holds true until you get to this step of actually connecting end devices, and the performance, the coverage that I've seen relative to Wi-Fi, it's pretty amazing. We did a proof of concept at a site recently, single indoor access point in a kit, little traveling kit that we built out. Attached it to a lift so we get it off the ground. I think that's key. Inside a 40,000 square foot warehouse that's, floor to ceiling, end to end, with metal racks, metal products on the racks. The single cellular access point covered that entire site. And outdoor results were equally impressive. But I think we do have to say, your mileage may vary. Every situation's different. We have tools to help us model applications before we go on site so we get an idea of what we're walking into. So site surveys we always recommend those and doing a detailed analysis. But you really, seeing's believing here. Okay, you mentioned it already. So to connect an end device to an access point, I just need a SIM card. So obviously phones and tablets, everybody's familiar with that concept. They'll take a SIM card natively. Computers, other devices, I'm seeing more and more. It's a standard that they have a SIM slot on them today from the factory. If not, certainly there are SIM adapters. We've worked with several different SIM adapters to connect computers and other things that don't have a SIM port natively.
And then on top of that too, you do have that eSIM, right? So I remember, again, just hearkening back to the good old days of my Wi-Fi youth. One of the things that we used to do a lot of the time for security was push certificates to client machines, right? And there were different ways to do that. You could do it through management tools, or you'd have to do a manual process called onboarding where the end user would have to do a lot of that themselves. But SIMs are known entities, right? People know how to put SIMs in their devices. So there's not a real training curve. And then two, for the admins that say they get 100 eSIMs for devices or something of that nature, mobile device management, MDM solutions are so common these days. Those admins and end users know the admins, the end users just consuming it, but they know how those things work. And so you can take the activation codes for those eSIMs and push them out to your devices just like you would a certificate for Wi-Fi or just any other type of profile information. So it's definitely a different paradigm, but once you do it, it's not totally different. It's just that in the plastic side, you're actually physically inserting a SIM. And if you're doing the eSIM, you're just pushing it out either with an MDM, or they'll also get QR codes. So you could just scan a QR code on your end device, and assuming it has a camera, that is, and move forward with that. It's quite simple.
And again, back to the point that with the Cradlepoint solution, all this is happening inside NetCloud. So that environment, that tool that so many customers use every day to manage their devices and their routers, that's the same environment where they're going to manage their NetCloud private network.
That's a great point. And that's also a really strong point, I would say, is the fact that with NetCloud private networks, the entirety of the management for the solution is all within NetCloud. So your SIM management, the core management, the AP management, and then all of that stuff is there, all the reporting. The workflow is very similar. There is only one exception. And one of the things that we do as a value add with our solution is we give access to a design tool so that you can, put a floor plan in or do a Google Earth image or something like that. That old adage of measure twice, cut once. And that's one of the things that we give access to as well. Now that is a separate product, separate sign-in, I should say. But nonetheless, everything else, the actual day-to-day running of the network, the configuration of the network, the maintenance of the network, that's all done within NCM.
So Greg, this design tool you mentioned, what can I do with that?
Yeah, so it's basically gives you the ability, again, you take a floor plan, you draw walls, or if you have a floor plan that's layered, say a PDF or DWG, you can have the tool draw the walls for you. And then you can, let's say a warehouse, right? Very common use case. You're going to have, like you mentioned earlier, one of your prospects has tall metal shelves and they have metal parts on it. You can draw what are called attenuation areas to see what's going to happen to that signal as it comes out of the access point and it hits that area. It's obviously going to be higher on one side that's closer to the access point than the other, but you can model that kind of stuff so that if you go into a warehouse, a building, an outdoor area, et cetera, you would go and you place these APs on the map and then you change the power, the setting, the height setting and things of that nature. And you can say, okay, if we put an access point at this particular part of this warehouse, this is what we think our coverage is going to look like. Because just with RF, and it doesn't matter what kind of RF you're using, too much RF can be a lot worse than not enough. We already know why not enough isn't good enough. You have coverage holes, you have poor performance, but too much can make things worse because you run into interference, bad data rates, things of that nature. So having this tool at your disposal gives you the ability to kind of visualize what that space is going to look like, throw some radios around, and then personal story. I can't tell you how many times I used to do these designs And then I'd go and give it to a customer and they'd say, well, we can't put that access point there because that's a boiler room or that's a bathroom or that's a locker room. Like, we don't want that in there because, I've not necessarily been on site. So it's like, okay, no problem. Let's move that out of here. And then let's put it somewhere else where I know I could put that to keep my coverage goals up. And then two, you may have certain situations like I've run into many times where you have a firewall and somebody doesn't necessarily want to run cables through that. Or maybe they already have cabling, but it's in this one particular spot and not this other one. So it just really gives you a leg up before you go on site. To Phil's point, though, a post-install validation survey is very, very important. Just to make sure everything looks good, get what it looks like in real life, tweak the signal, tweak the all the little knobs and bells and whistles. But it's a very nice add-on that comes included with the product.
So that's a service that we offer at INS. So I mentioned we've built a small rugged case that we can take on the road to do basic proof of concept or proof of technology demos on site. So that's a function that's free of charge. Again, with those, height is your friend. So if we've got a way to get the access point off the ground, whatever that might be, a lift or a mezzanine or a ladder, the side of the building, whatever. If we can get it off the ground, that certainly is going to improve performance. We've got some tools that we use to walk the site, take readings and measurements at multiple points around the site. So that's a sales demonstration. From there, we have the ability to do a full site survey and an audit. So that is a much more detailed exercise as far we get into very specific locations of where access points would need to be mounted, antenna orientation, where and how is the core on the VM, where's that going to be installed, where's it going to run and reside. If the customer doesn't have that environment, that's something we can provide, more of a turnkey solution. What we've seen, projects we've done, and we've deployed about a dozen now. The private cellular technology is, frankly, that's the easy part. The devil's in the details as far as going back and really dealing with the end devices and policies related to those, user policies, security policies, and how that gets implemented. We usually spend more time on that aspect than getting the network functional. So the output or the deliverable of our network audit is basically a project plan and everything you need and all the details to implement a private cellular network on your site. And with that, we include pricing on, for us to deliver that service for you, turnkey or in whatever aspect that we need to own. We're able to give you a price to do that with the audit. Okay, Greg, let's talk a little about some of what we've seen out there, some applications and use cases. I've seen marketing material from different companies that talk about coverage relative to Wi-Fi. So tell us how Cradlepoint views that and what you might expect to see, say, with one Cradlepoint access point, what kind of coverage could I get compared to X of my Wi-Fi access points that I'm familiar with?
Yeah. So what we kind of say from a marketing perspective, generally one cellular AP for every 4 Wi-Fi APs. Again, and this is your mileage may vary. It's going to depend on what your solution is doing. So, but one real world example, I was at a warehouse last week with one of our customers, and they had installed 4 of the Cradlepoint indoor radios. They had 12 Wi-Fi APs just in the warehouse. And upon further testing and some tweaking, we saw that we could actually cover not only the warehouse, but the entire office facility. They had some production facilities outside of the warehouse. We could cover all that with one AP. Now, am I telling you should do that? No, I'm not. I told them that even, going back in time, if we could have done this a little differently, I still would have done 2. One, higher performance, some load balancing, but also failover. If a switch port went bad or a cable went bad or an AP went bad, at least you still got something. May not be ideal, but you got something. So in that case, we're a little higher than that, 1 to 4. But again, it's going to be very highly dependent on the design, the use case, and stuff like that. What are you seeing, Phil?
I've seen similar. I think that's a conservative number. And I'm like you, I'm a little reluctant just to throw throw numbers like that around. But I will give you one example, a project that we did last year. And it was almost a perfect environment for a private cellular network, but it was, large outdoor facility, lots of metal, challenging for Wi-Fi. The customer already had a proposal. They'd already done a Wi-Fi site survey, and they were headed down the road with that project. It was going to be in the neighborhood of 130 outdoor Wi-Fi access points. So we said, hey, let's take a look here. Let's see what we can do with a CBRS solution. We covered the entire site with 3 CBRS access points. Performance was, everything about the project was a fantastic success. So again, that's probably the extreme scenario, and that's everything, perfect case by perfect case, but still the results we've seen with this technology are pretty staggering.
I bet some poor salesperson is now crying.
No doubt. I've thrown around the acronym CBRS quite a bit. So Greg, you and I use that a lot, and we use that interchangeably, I guess, with, private cellular networks that you'll read about online, or PCN. You may see and hear about private LTE. You see a lot today about private 5G. You think we ought to take a step back and let's get into a little bit about what CBRS is?
To kind of talk a little bit about CBRS. So that stands for Citizens Broadband Radio Service. So back in 2015, the FCC released a bit of frequency in the 3.5 gigahertz, specifically 3.55 gigahertz at 3700, so 150 megahertz wide, of use for the common person. There was a lot of government use in there. The DoD, specifically the Navy, was using that. There was also some terrestrial satellite receivers that were in that band as well. A couple other things, but it wasn't really saturated. And a lot of those users save the government in certain scenarios. It was going unused. So because we were seeing, like Phil said, kind of beginning when we were talking about private cellular, there was a desire to get something like that in common people's hands, but not have to go through a carrier. And they saw this band just wasn't being used. I shouldn't say not used, not efficiently used. It could be used better. So they opened this band up, and you started seeing a lot of big players in the industry start getting interested in it. So what they were trying to do was give people the ability to go and use cellular type frequencies and the technology and, the benefits of cellular and get it out. So the CBRS is that 150 megahertz. There's 3 tiers of users in that. So you have your top, think of it like a pyramid, right? So your top, those are the incumbents. That's like the government. There was some broadband, but those licenses have since expired this year, 2023. And then also there are some satellite receivers, but those are few and far between, and their licenses are going to expire too if they haven't already evacuated the band. So you have that side, right? So that's incumbent. They always win. And usually when we talk about incumbents, we're thinking the military, Navy specifically. Then you have your second tier, which is called your priority access license. So even though this band is somewhat unlicensed, there was this PAL that was given out or auctioned specifically for certain folks. It was done back in 2020, and it was done county by county. So people could buy that. The reason you may want to do that is to try to get channels that you would be preferred on so that other people around you couldn't broadcast on that. But then you had your third tier, your bottom tier, which is called general available access. So what that is any user that has an access point, the core, or eNode B, whatever you want to call it, they have that stuff. And you have to have what's called a certified professional installer. You have to talk to a Saas, which I'll get into what a Saas is in a moment. But that's anybody can get on there. So in that sense, you can think of it, again, like Wi-Fi, where, if you get a Wi-Fi AP at home, You just turn it on and it works in either 2.4, 5, or 6 gigahertz, depending on what kind of an AP you have. Now, the difference being that Saas I just mentioned. So Saas is spectrum allocation service. There are a few vendors that offer this service currently. But basically what they will do is with your access point, you have to have some GPS coordinates in there, whether you put them in manually or you have a GPS receiver on the actual access point that can report back. And the Saas will take the data from a certified professional installer. You put that in, and then it signs that AP and gives you what's called a grant. And your grant is going to consist of two different things. One is going to be your channel, which could be 10 megahertz wide, 20 megahertz wide, 40 or 50, or 30 as well. And I should say, it's going to give you your power. So most places in the United States, you can transmit at the fully available power, which for indoor, it's 30 dBm. For outdoor, it's going to be 47 dBm, or 1 watt and 50 watts respectively. So there are certain areas where you can indeed have CBRS radios running, whether indoor or outdoor, but maybe you have to have a reduced power. Or maybe there's a certain channel you can't use because maybe the Navy's using it or something of that nature. So that's kind of CBRS in a nutshell. If you've ever heard politicians or you've read on news sites or Twitter or something like that, you hear the innovation band here in the United States, that's CBRS. It's the exact same thing, just a marketing name for it.
And I think that's the great thing about it. Like you said, you get a grant to transmit that defines channel and power. So if you think about it, that's one of the problems we see with Wi-Fi, especially if you're in my office is in a downtown area. So when I look at available Wi-Fi networks, I see 40 that I can pick from. So it's a very cluttered and crowded airspace. With CBRS, it's unlicensed, but it is shared and managed spectrum. So nothing's going to transmit until you get a grant. And the point of the grant is to make sure that you're using channel and power, antenna orientation, all the network parameters. So you're not going to step on your neighbor's network if they happen to be using CBRS also. So you're going to get consistent performance, and not have to worry about, overcrowding or saturation. So the role of the CPI here, the certified professional installer, is really critical. So their job is to register the devices on the network and make sure it's entered correctly. So you're entering, what is the equipment, which carries over the specs on the equipment, GPS coordinates, the height, the direction of the antenna, the orientation of the antenna. All these things get entered correctly. So then that CBRS ecosystem works and the networks perform really well for everybody, for all users.
Yep. Yeah. And in fact, in the Wi-Fi world, with the 6 gigahertz band being given to the people, they're going to have something very similar to what we call the Saas and CBRS. It's going to be called automated frequency coordination, or AFC. So they're going to have something very similar to do themselves. Now, I don't know if there's going to be something like a CPI or whatnot, but the access points are going to have GPS. They're going to have to tell height. They're going to have to do all of that stuff. So this will be, I guess you could say, us in the private cellular land were the forerunners of it, but all my Wi-Fi friends are going to have to contend with this too in the future. But it has a lot of benefits.
Definitely. And that's a service that we can perform at INS. So we've got CPIs on staff that can register your equipment and get the project done right. Another thing we should note, we talked about the Saas and how it manages traffic. So is that one and done thing, or does my network check in with the Saas periodically? Let's go a little deeper, Greg, on how the Saas works.
Yeah. So the Saas, you have a heartbeat for the access point, or what's called a domain proxy, which we'll save that for the next podcast. But you'll have a heartbeat back to the Saas. And so that's just basically saying, hey, I'm still here. And you may say, like, why do I need to do that? Well, you don't want somebody to grab that same grant that's sitting next to you because your AP failed to heartbeat. If your AP is trying to be on one channel and then somebody brings up one next door and it's the same channel, well, we all know how that works in Wi-Fi. It doesn't work much better in cellular. So the thing to consider when doing that is having a good internet connection, because they do have to talk to the internet, right? Now, some people get a little upset about that, but when you start thinking about just how business runs in general, think about how many applications you have that run in the cloud. Think about how many network pieces of network gear or OT gear or something like that that needs to have a cloud connection for data processing, control, management, et cetera. So having a good stable internet connection, a backup internet, things like that. Because I'm guessing here, and I don't have a good track record with my crystal ball, but I'm going to throw this out there anyway. I think more often than not, most customers, most businesses, period, most people, if you don't have internet access, business is going to stop or slow to a crawl. Just think about kids. Like the Wi-Fi goes down, you don't have internet access. I mean, I don't know what it's like for you guys, but for me, it gets a little scary in my house when I don't have Wi-Fi or internet. So, but anyway, in all reality, though, you need to have that. So that SaaS I think ensure is a little too strong of a word, but it will help to make sure you're not going to have somebody come and steal that channel out from under you. So that's why you're going to have this heartbeat kind of thing going on. Also, I mentioned those 3 tiers of users earlier. So let's say perhaps you live on the coast, or you've got a customer on the coast, or an office on the coast, and a Navy, I believe it's mostly aircraft carriers that still use some of that band. If an aircraft carrier comes through and you're on the same frequency, you're done. Sorry, it's going to happen. But because we're doing that heartbeat and we have that constant conversation with the SaaS, it can say, okay, you can't use this channel anymore, but here's another one I got for you. So will you have a potential interruption? Yeah, but it's going to be very, very small. So, but at the end of the day, though, that's going to be a corner case. I think I read a study by Ericsson where they said as far as the SaaS having to make emergency changes like that, it was less than 0.0001% of all of the different devices running on the CBSD network at the time. So it's very, very small.
That's a really important point you made. So if an incumbent comes into my area and I happen to be on one of those channels that are reserved for incumbents, if I got a grant that happened to be on one of those channels, I get bumped. Is that right? My access point gets bumped from the network. So my network is going to get reassigned, or it's going to get a new grant asking it to broadcast on different channels. So it's not that I don't have a network anymore. Is that right?
Phil's absolutely right. This is going to be one of those things that your access point gets what's called a suspension or a termination from the SaaS. It goes and says, okay, I need a grant. So it's going to go right back out and ask for another one. And the process of getting a grant is usually milliseconds. It doesn't take a long time unless your internet goes out. That's a different story. But yeah, so but all the advantages of having that to make sure you're not getting stomped on by other people, or just think about going to like a football game or a baseball game or a play or something, which I hope you don't go to a play and use your cell phone, but you get into those very high density areas and you see service interruptions like that because it's so dense. There's numerous access points all radiating on similar channels. So that's one of the things the SaaS helps end user networks to avoid. So that's part of the reason the SaaS is there.
Understand. So we've talked to some customers, and like I said, the ones we've deployed so far have all been at the GAA level, or at the lowest level of that pyramid. So if I wanted to look into getting a PAL and have priority license, that auction already happened. And those were sold on a per county basis. So it's not like I can go back and try to buy one today. But there are ways that you can still acquire a priority access license, even though the auction is in the past. So we have relationships with brokers that are companies that are in the business of identifying spectrum owners and selling or leasing those rights to other people. So if that's something, and we get into your application and we really think a PAL might be important and valuable for your network, that's certainly something that we can help you with.
Let me ask you a question. So you get a prospect, or maybe you've got an existing customer that says, hey, Phil, come talk to me about private cellular. What are the questions they're asking you? What are some of the common responses? And maybe too, what are some of the questions you ask them so that they better know what it is they need or what they want to use it for? Kind of, refine that a little bit.
Yeah. So it's probably the first thing that we try to identify is what is the use case? What's the problem that you're trying to solve? So we've seen lots of customers today, and there lots of trends talking about industry 4.0 and digital transformation and those sorts of things. And I guess what we see, and those are all important and great things that are happening in the world. So I don't want to make light of those. But what we've seen is when we walk into a room, and we're kind of ready to talk about a private cellular network, talking at that, 40,000 foot level, and, big blanket statements about enterprise strategies and things of that sort. The INS, I guess, we're a much more tactical kind of boots on the ground company. So we like to take the approach of, hey, let's pick an application. Let's solve a problem you've got today, or you see a need for something or for some technology. It could be as simple as electronic documents to, work orders or parts management or a safety plan. So I need authorization to go in a restricted area. Let me get a digital signature for that. Let's pick one application and let's see how we solve that. So understanding the use case, what they want to do with it, because then that sort of guides the design process. So now we understand, okay, what are the devices that are going to get connected to the network? What kind of bandwidth requirements are they going to have? Certainly, what kind of coverage requirements are they going to have? Are these moving? Are they going to be roaming? So the mobility element's important. So all of these things, we really try to get really down to, user level, what's going to be happening, and put in just a bulletproof network that blows them away with the performance that they get out of it. And then what we've seen is that's a pretty eye-opening experience to the customer. And then they start to recognize all the other opportunities to apply that technology. So, all the usual questions when you're buying or investing in some sort of a network technology, just like all the questions you would have about, deploying a Wi-Fi network. We have all those conversations, coverage and users and everything. Security certainly is a big element. But again, our approach is always kind of start small and then manage the growth. And as you add on more users and more applications, I guess that's been our approach.
What have you guys done at INS? Like, what are some customer problems you've solved deploying private cellular networking?
Okay, so probably the most recent one we did was an AGV application in a manufacturing plant and a warehouse. And the problem there was really about Wi-Fi coverage. They could just, their Wi-Fi coverage was not dependable. And it was a unique application in that large indoor space, but you also had large outdoor spaces that they had to cover on all four sides of the building. So we replaced the Wi-Fi network in plant and outside. And, overall it was probably a 4-to-1 migration. So one CBRS access point for about every 4 to 5, I guess, Wi-Fi access points that were previously installed. So let me think. So we've deployed private cellular networks at a quarry, cement plant, at an oil refinery, at a large shipping port. We've done an LNG facility, a chemical plant, and we've done a couple of autonomous vehicles, outdoor applications. Think agriculture type applications. They're lots of cool things happening in that space. And then AGVs. So, and like I said, each one of these, I think we've taken the approach of, a very specific application we were solving. So one was all about, maintenance requests and work orders. And it was the time lost in physically traversing the site, to get a paper form or to get a paper form signed and then, go get your hands on a part and back to, and being able to do that, all on a tablet, and to where you place the order for the part. By the time you get to the storehouse, it's pulled and it's ready and you're back. You're cutting that turnaround time in half at least. So in every one of these, I think that's what was pretty cool. In every one of these, it was a very specific point solution that we were able to provide this connectivity, that enabled that application. And that's kind of, I guess, our modus operandi is, let's find a point solution and figure out how we can solve that problem. And then when we've done that, then you start to look around and see other things that are now enabled because you got this kick butt wireless network to run with. So once the network's deployed and it's running and the customer really sees what they've got, it opens up so many more opportunities, for applications that they either hadn't thought about or hadn't thought possible up until now.
A lot of the times what I'm seeing, kind of the big use case, AGVs, definitely a big one I hear about quite a bit, especially because AGVs and manufacturing go hand in hand. So that's definitely one that's been really big. One thing that was a little newer to me, you spoke about, like IoT, was something I didn't quite think about, but I should have known, is better battery life. So cellular devices tend to have better battery life when it's just running on cellular. And so we found one of our particular clients was saying that they noticed they had decent Wi-Fi coverage in their facility and they were using the Wi-Fi scanners, but then they were upgrading. They said, you know what, why don't we look at getting a dual, a Wi-Fi and a cellular? Because at that point too, you do have a failover mechanism if one or the other goes down. So they noted that once they moved those scanners over to cellular, they were getting about 3 to 4 more hours of battery life on those than when they were just doing Wi-Fi. So they're looking to do an IoT initiative. And a lot of those sensors, like if you remember the BLE craze of, 5-6 years ago, maybe longer than that, but you see a lot of these different sensors that are going on in these warehouses or in stores, locationing, safety, temperature, environmental, et cetera. And a lot of those are battery operated. So what people are finding is that if they actually do a cellular one, it may cost a little more upfront potentially, but it's going to last a lot longer. So the ROI is going to be much higher. So I'm seeing that quite a bit. Video surveillance, like you were saying, I see that a lot, especially because of that range and the throughput you're getting. You could put a camera, maybe a little further out and then just connect it back to the access point, get good throughput, you get much better range. So those are probably the biggest ones.
On sensors, the total installed cost. So if you're not having to run power to every device because it's got a battery in it instead, that's a huge cost savings to that end user.
There is one other one that I just thought about. I made that analogy to Wi-Fi being in a stadium or something like that. So we've talked to one particular stadium where they want the Wi-Fi to be fan-facing, fan experience, food ordering, yada, yada, yada. But for the in-house staff, for security, for ticket takers, for concession stands, yada, 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 they want them to have devices that run off that CBRS network. Because at that point, it's truly private. You can only get on that network if you have the eSIM, you have the physical SIM, you have to have a device that supports it. But that way, that spectrum, even though the Wi-Fi might be very crowded at any one point in time, that spectrum is very, very available and very, very performant, even in the middle of like a very large championship game or a Super Bowl or et cetera, et cetera. So that's a huge, huge selling point too. I see that a lot, especially for POS. I had one particular customer, prospect to be clear, tell me that their POS terminals at some games could lose 6 figures because the internet connection was so flaky. And I'm like, That's insane. 6 figures in 1 hour. Now, granted, this is multiple terminals, but still, that's a lot of money.
Good point too, Greg. So we've made the assumption so far that any cellular device or anything that I can put a SIM card in or an eSIM will work. But we should probably be really clear on that and say, in CBRS, it requires, the end devices have to support LTE band 48. So you'll actually need to check the specs of the devices to make sure that band 48 is supported. So that's one of the things that, when we do an audit, we get into those details about the use case, the application you're trying to solve, and the connected devices. So we're able to, identify early on if the devices that you're using today are compatible, or are you going to have to, get new devices that support CBRS band 48. So those are the details that we get into when we do a network audit.
And that's a really good point. And, with Apple had their big announcement last week about the new version of iOS. And one of the huge things they talked about was private cellular. So it is, in my opinion, having been in the vendor industry for so long, especially in Wi-Fi, we would always see the rest of the industry start following a newer technology, like when one new version of Wi-Fi came out from, say, like AC to AX. When Apple released a device that supported it, that's when it was real, right? And I would say that's kind of what we're seeing here with private cellular. But that said, Apple devices since, and do correct me if I'm wrong here, Phil, but like since 2020 will support at least band 48. All the devices that'll do 5G will support N48. Android devices, mini, and again, your models may vary. There's so many different ODMs out there for Android, but just look on their spec sheet and see if they support it. A lot of them do. I know like handheld scanners from a lot of the big names that are supporting that kind of stuff as well. So it's coming very, very, very fast.
Right. That ecosystem has matured in a hurry, for sure. I know we've done one private 5G deployment, and really that was the stumbling block, was finding compatible devices, because that ecosystem is just not as mature.
Yep, definitely wise words. Need to watch out for that. Make sure your device supports it before you go and buy a bunch of stuff and have heartbreak when it doesn't work.
Okay, Greg, we've covered a lot today. Thanks for your time, and thanks to our viewers and listeners that have made it this far with us. If you'd like to send us questions or find out more about Cradlepoint's NetCloud private networks or CBRS and that technology, we'd love to talk to you about it. You can connect with INS at our website, which is industrialnetworking.com. You can send us an email or fill out a form and request that we get in touch with you. Likewise for Cradlepoint, and we'll put some links up on the screen so you can reach out to us directly. We'll do a round 2 of this and get go a little deeper into some technical details and answer some viewer questions. Thanks, everybody.